Okay, all right. Let us now find out the inverse of a 3 cross 3 matrix. Let me do one example instead. Okay. Suppose I do number 15. Let A be your given matrix. So I'm going to write A as 2 minus 3, 3, 2, 2, 3, and then 3 minus 2 and 2. So this is a 3 cross 3 matrix. So we follow the same rules, the same procedure. We know that any matrix A is equal to the identity matrix into A. Now A is your 3 cross 3 matrix. 2 minus 3, 3, 2, 2, 3, and 3 minus 2, 2. I is identity matrix of order 3 now. 1, 0, 0, 0, 1, 0, 0, 0, 1 times A. So we are going to convert the matrix on the left hand side to the identity matrix, right? Your identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So how to do it? First of all, you have to convert this entry of row 2 and this entry of row 3 to be 0 simultaneously. In order to convert this entry of row 3 to as 0, you cannot use row 2 because both of them are going to undergo transformation simultaneously at the same time, okay? So in order to convert this entry to 0, you have to use row 1, and in order to convert this entry to 0, you have to use row 1 only in both the cases, okay? Or we can do like this. Itu get 0 banabo goile, itu ikbar rakhibi, itu get 0 na banabe. First ki kuribo, itu get 0 banabo goile row 2 ge use kuri na ole 0 banabo paribo. To do them the row 2 ge ko transformation na jaboni. Okay? But in order to save time for 3 cross 3 matrix, what we can do is we can convert both of these entries of row 1 and row 2, okay, to be 0 simultaneously by using row 1. Okay. So how are you going to use row 1 in order to make this entry of row 2 to be 0? Row 2 ge kinaka operation perform koribo using row 1. See, it 0 banabole entry ikta 0 banabole do. You need to make use of the another row, right? But I cannot use row 3 because it is also going to undergo transformation. So in both the cases, let's use row 1, okay? So what kind of operation will you perform on row 2? Row 1 use kuribi na a row 2 laga itu entry do 0 banabi. Yeah, to R2 minus R1 jawna. Is it okay? Yeah, I can close the light because it will cause more reflection. Okay. And then R3 be simultaneously. Let's go for R3. This entry of R3 has to be 0. So what kind of transformation do you have to perform?
Using R2 and R1.
No.
R3.
R2 is also going transformation. So in order to make this entry as 0, I cannot use R2. In both the cases, I have to make use only R1. No? So first of all, let's talk about this entry of row 2. I want to make this as 0. So let's make use of R1. Okay? So row 2, what kind of operation are you going to perform? R2 minus R1. So that 2 minus 2 will be 0. Then what about row 3? What kind of operation are you going to perform on row 3? 3R3.
2R3.
Yeah. You multiply row 3 by a non-zero scalar 2 and subtract it with trace of R1. Then both of these entries will be 0 simultaneously. Okay? It's alright, no? 2 minus 3, 3. This would be 0. If this is 0, then this would be 2 minus of minus 3. Okay, that is 5. And then 3 minus 3, 0. No? Automatically this has become 0, so easier for us. It will be 0 automatically. Kiloguli tai 0 ba na boli hi tu rasido na to direct 0 likhi. Tai garne do 2 times minus 2. 2 times minus 2 is minus 4. And then minus of 3 times of minus 3
plus 9.
Yeah. 2 times of minus 2 is minus 4 now. Minus 3 times minus 3 is plus 9. So that's 5 again. No? And then this will become 2 times of 2 is 4. 4 minus 3 times 3. 4 minus 9. Minus 5. Okay? Same operation has to be performed here. Here we cannot see. Same operation, we will perform it here. So R2 goes for R2 minus R1. 0 minus 1, minus 1. 1 minus 0, 1. 0 minus 0, 0. This is easy. 2 times of 0, minus 3 times 1, minus 3. 2 times 0, minus 3 times 0, 0. 2 times 1, minus 3 times 0, 2. It's alright, no? Okay. Now the next thing is, look here, this entry has to be 0, no? This entry of row 3, no? This entry, first itu laga khotom koribo de, itu duita banaishido na, itu aibo, next itu hobo no. Row 3 laga first khotom koribo. Itu entry ke kinaga 0 banabo. Itu ke 0 banabo li nimite, you have to make use of the neighboring rows, right? 0 banabo ko ile to neighboring row e bhabibo. Itu ke 0 kinaga banabo. Itu ke 0 kinaga banabo. Instead of using R1, I can use R2 because same entries, right? We can just simply subtract. Tai do change no godo. Kilo gule tai 0 is already na. So row 3 goes for row 3 minus row 2. Okay? Elements of row, to the elements of row 3. To the elements of row 3, you subtract corresponding elements of row 2. Right? That's the perfect way to say. To the elements of row 3, subtract elements of row 2. Corresponding elements of row 2. Huh? I think I should have said in the previous case the same way. No, to start with, just said, brah. 0, 5, 0. 0 minus 0, 0. 5 minus 5, 0. Minus 5 minus 0. Minus 5. It will be fulfill. It will be fulfill. It will be fulfill. It will fulfill. It will give 1 banao. 1 banao bole to dusra neighboring row na sawo hoile bi to na khoribo. Tage de nai do. Tage bi transformation to dibo. It will give it same transformation. 1, 0, 0, minus 1, 1, 0, minus 3, minus, minus, plus 1. Minus 3 plus 1, minus 2. 0 minus 1, minus 1. 2 minus 0, 2 and, no? Oh, I'm going to make this as 1. Did you 1 kina ba na ba? 1 banabo gole do divide multiply karibo. R3 goes for R3 upon minus 5. So in that case, this becomes 2 minus 3, 3, 0, 5, 0, 0, 0, 1. Okay? And this is now 1, 0, 0, minus 1, 1, 0, minus, no, minus 2 divided by minus 5. 2 by 5, yes, it's correct. 1 by 5, alright, no problemo.
Minus 2 by 5.
Yeah, minus 2 by 5, yes, correct. Question last row 3 la interest to. So question row 2 la interest to. Itu 0 agi di bane she. Idi 0 hobra la kese to me. Kile bole itu first 0 bana bole lagi. Tu duita bi 0 hoshi bole itu ge 1 bana bo. Ah. Tu itia do tai bi 0 hoshi automatic pra tai ge 1 bana bo ni. To 1 bana bole to ikube transformation neighboring rows na pabibo. Ki koribo? Divide kori dibo ni na. Divide by 5. So R2 goes for R2 upon 5. Then your matrix is 2 minus 3, 3. 0, 1, 0, 0, 0, 1. Same transformation we have to undergo for this matrix. I'm dividing row 2 by 5. All the